Okay, so I have a couple more graphs here about quadratic functions before we are ready to put it all together and draw some nice pictures. All right, so let's say I give you y equals x squared and I give you y equals negative x squared. Then what's going to happen is it's going to take all of our y numbers, multiply them by -1 and make them negative. In other words, it's going to take y equals x squared and simply flip it over. So there's how you get your parabola opening downward. When this number out front is negative, you get a downward facing parabola. Y equals x squared and y equals -3x squared. Two things happen here. The negative flips it, and then the 3 is what we were talking about at the end of the first video. That's a vertical stretch. It grabs the ends and pulls it down. In essence, it makes it look skinnier. All right, so let's put this all together. Standard form of a quadratic function. Y equals a times x minus h squared plus k. I tend to call this vertex form instead of standard form because h and k tell us the vertex, because we saw that the h takes the vertex and shifts it left and right. The k takes the vertex and shifts it up and down. So our vertex is going to be h comma k. Again, watch out for your signs. If this is a minus here, this is going to be a plus here. If this is a plus here, this is going to be a minus there. The k will work the same. K will be, if k is positive, k will be positive. Our axis of symmetry is the line that goes right through the vertex, so that's always going to be x equals whatever this h number is. A controls the direction. If A is positive, the parabola opens upward, a big U. If A is negative, the parabola opens downward, big upside down U. And A also controls the width, although again it's really not width, it's really how's it being pulled up or down, pulled in and out, stretched. All right, so let's put that all together. Y equals 2 times x plus 3 squared minus 4. Determine the vertex and the axis of symmetry for each of the following, and then graph. Well, the first thing I would say is my vertex is the point -3, -4. The number inside the parentheses controls the left and right. Since this is a plus 3, it's going to be shifted 3 to the left. The number outside the parentheses controls the up and down. So that's a -4. It's going to go down 4. And then I know my axis of symmetry is x equals -3. It's always x equals whatever that number is. All right, so I have -3, -4. That's right here. Then what I would do is I would build myself a little table, and I would plug in some numbers. Now, I think the general rule is pick two numbers bigger than whatever this is. So I'm going to use -2 and -1. And then pick two numbers smaller, -4 and -5. I plug in -2. -2 plus 3 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 4 is -2. Put out right there. Plug in -1. -1 plus 3 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 4, is 4. -1, 4. Now, the good news is I don't really need to plug these two numbers in and figure them out. Although I could, and it would be a good check of my arithmetic, but I don't need to. Because here's what I talked about before with the symmetry. If I took one step to the right there and ended up at -2, when I take one step to the left, I'm also going to end up at -2. So I know I'm going to have the point -4, -2. And if I started at my vertex and took 2 steps to the right and ended up at 4, then when I take 2 steps to the left, I'm also going to end up at 4. So do you see how computing points for a parabola is pretty easy? Once you have 2 points on one side of the vertex, you have 2 more points on the other side of the vertex for free. And notice this number was a positive here, so we should have expected this parabola to open upward like it did. y equals -3 times x minus 1 squared plus 5. Alright, first thing I would do is write down my vertex. My vertex is going to be 1, 5. This controls the left and right. Since it's a -1, it goes 1 to the right. This controls the up and down. Since it's a +5, it goes up 5. My axis of symmetry is x equals 1, whatever that number is right there. 1, 5. The next thing I should know about this parabola, because this is a negative right here, I should know that it's going to go downward roughly. Again, I'm going to plug in a couple numbers. I'm going to pick a couple numbers bigger than 1 and a couple numbers smaller than 1. And again, I only have to compute half the points, really. When I plug in 2, 2 minus 1 is 1. 1 squared is 1. 1 times -3 is -3. -3 plus 5 is 2. So without doing any work, I know when I plug in 0, I'm also going to get 2. Because I went 1 step to the right, 1 step to the left. Plug in 3. 3 minus 1 is 2. 2 squared is 4. 4 times -3 is -12. -12 plus 5 is -7. 3, -7, which means I'm going to have, by the same logic as before, -1, -7. 2 steps to the right, if I end up at -7. 2 steps to the left, I will end up at -7. So we see we get what looks like a very skinny parabola, which shouldn't surprise us because of that 3 right there. Okay, so that's graphing equations in vertex form. Now we're going to take a look at graphing equations in general form. General form is probably the more commonly written form of quadratic functions. Y equals ax squared plus bx plus c. We'll be looking at this sort of thing a lot coming up in the near future in this course. So, the first thing it says here to do is determine the vertex of y equals x squared minus 6x minus 4 and graph the equation. There's a unique way to find the vertex. It's really kind of a cool thing. What we do is we're going to plug in a number. We're going to build a little table. We're going to plug in a number. But we're going to do kind of a strange thing. Always, as far as I know from what we've done, we've picked up numbers for x and we've plugged them in. This time we're going to pick a number for y and plug it in, which seems like a very strange thing, but you'll see how that works in just a minute here. So since I have x squared minus 6x minus 4, I'm going to plug in -4 for y. And I'm going to end up getting 2 answers because of the symmetry of a parabola. So whatever this number is right here, you plug that in. And you're going to get 2 answers. Now, how do I find the 2 answers? Well, I have to go off to the side here. I'm going to plug -4 in for the y. The reason I picked -4 is the first thing I would have to do is get 0 on one side, which means I add 4, and that reduces those. You end up with something that you're guaranteed will factor because the constant term goes away. I can take out a GCF of x, which means I get x equals 0 and x equals 6. So I have 0 and 6. So I have 0, -4 and 6, -4. So now where's the vertex? Think about that just for a second, and now I'll give you the answer. The vertex happens, oops, I went too far. I went all the way to 8. There's 6 right there. The vertex happens at x equals 3. Why does it have to happen at x equals 3? Well, it goes back to the symmetry property that we were talking about. If I have 2 points at the same height, the vertex is exactly halfway in between. Same thing happens here. If I have 2 points at the same height, the line of symmetry is right in the middle, which means the vertex is right in the middle. So this is our kind of unique way for finding the vertex. We use the fact that we can set y equal to that number. It will eliminate, allow us to factor. It'll give us 2 points at the same height. Once we have 2 points at the same height, the vertex has to be halfway in between. So what I have to do now is take the number 3 and plug it in. Plugging it in as an x number. When I plug in 3, let's see, I get 9 minus 18 minus 4. That's negative 9 minus 4. That's negative 13. Well, I can be close, I guess. 3, negative 13, right there. And notice that's kind of a neat trick, because not only does it give us the vertex, it gives us at least 1 point on each side of the vertex. If I wanted to figure out some more, I could. Really don't need to. Another quick thing to point out, since this was a positive in front of the x squared, we knew the parabola was going to open upward. Which brings us to this one, where since we have a negative in front of here, we know, if nothing else, this parabola is going to open downward. Alright, well, to find the vertex, I plug in whatever number that is right there for y. So 1 equals negative 2x squared minus 4x plus 1. Subtract the 1 on both sides. 0 equals minus 2x squared minus 4x. The 1's reduce out. I can factor. I take out a negative 2x. Left over is x minus 2, which means I'm going to get negative 2x equals 0, which means x is 0. X minus 2 is 0, which means x is 2. So I get 0 and 2. That gives me 2 points at the same height. 0, 1, 2, 1. Which means my vertex has to be halfway in between. My vertex has to happen at x equals 1. Plug 1 in, I get negative 2 minus 4. Oh, rats, I made a mistake. I made a mistake right here. When I factored out the negative 2, sorry about this. When I factored out the negative 2, see, this is a very easy mistake to make. I warned you about this before. When you factor out the negative, that sign right there has to change. I warned you about that when we did factoring, and then I just made that same mistake myself. See how that can happen? Everybody screws up. So that becomes an x plus 2, which makes that a minus 2. So ignore that point. It should be over here. Which means my vertex happens at x equals negative 1, halfway between 0 and negative 2. Alright, sorry about that mistake and making a mess there. It happens. We all goof up occasionally. Alright, plugging in negative 1. Negative 1 squared is 1. 1 times negative 2 is negative 2. Negative 4 times negative 1 is plus 4. And then a plus 1, so that's 5 minus 2, that's 3. Now, the reason I knew I made a mistake back here was because I knew this was a negative, so I knew the vertex had to be the highest point. And when I was plugging in 1, I was getting a point down here, which was going to tell me my vertex was a low point, and I knew that had to be wrong because of that negative right there. So that's how I knew I made that mistake. Hopefully you'll be a little more careful in your work and you won't make that same mistake. Okay, so we have one more little video to make for this section, and then we'll be all done.